Welcome back. So, as we just mentioned before in part 1, we will discuss about super basic things in matrices like entries, name, size, and the operation that can be applied on a matrices. Alright, so a matrix is a rectangular array of numbers such as this. Alright, we usually use matrices on modeling a variety of real-life problems and in programming array data structures as a matrix. We often use capital letters to represent a matrix, and for the one we have here, we chose A to be the name of this matrix. Now, if you can see, a matrix has a size, and the size is a dimension of a matrix. So here we have 2 rows and 3 columns. Therefore, we can just call A as a 2 by 3 matrix. And we can write the size of a matrix on the most right side outside the rectangular array. Now, number 1 in matrix A can be called as a matrix entry, and we identify the numbers inside by their position. For example, A is the entry is in first row, first column. So we can also use the shorthand A11 to indicate that A is in a first row, is in a first row and the first column. Let's see same matrix but with different entry. And here we have 2. If you notice, 2 is in our first row and in a second column. Now try by your own to find what is in A23 and what is in A21, and where can we find -3 and where can we find 4. Alright, so a matrix or a 2 matrices can be equal if they have same size and the corresponding entries are equal. What do we mean by a corresponding entries? We mean that in a matrix A, A11 should be equal a matrix B, B11, which is the entry in first row, first column in 2 matrices should be equal, as well as the rest of entries. Therefore, we can just call 2 matrices are equal. Now moving to the matrices operations, we will see 2 types of multiplication. The first one is scalar multiplication. The second one is when multiplying 2 matrices. For scalar multiplication, if we have C as a real number and matrix A, then CA will equal that each entry in a matrix A will be multiplied by C. For example, if we have this a matrix which is 1620 and we have C as 1/2, then CA will equal, or 1/2A will equals to, we just multiply the C, the real number, by each entry in a matrix. Therefore, we got 1/2, 3, 1, and 0. Yeah? Alright. Moving to our second matrix operation, which is addition. In order to add or multiply or subtract, we need just to make sure that the size of the matrices are met as specific restrictions. For addition, matrices A and B should be of the same side. Then we can just add the corresponding entries. Example, here we have matrix A and matrix B. Matrix A is 1 0 0 2 2 minus 1, and matrix B is 3 6 5 minus 3 0 1. So here we have in B of the same size. Then we take each corresponding entry and add them together. As you see here, 1 plus 3 is 4, 0 plus 6 is 6, 0 plus 5 is 5, and so on for the rest of entries. Let's see another example where we have a matrix of 3 by 2 and the second one is 3 by 3. Then the addition or the summation is not defined because the two matrices are not of the same size. For difference, it will be almost same as subtraction, almost same as addition. And we can just write it in another way, like A plus minus 1B. For example, if we have those two matrices, first you need to make sure that they are on the same size. Then you take each corresponding entry and you should subtract them. Or if we wrote it in the other way, then we first need to multiply the second matrix by minus 1. We'll change the sign of matrix entries, then we just can add it. So in here we have 1 plus 1, because minus 1 times minus 1 is 1. So 1 plus 1 is 2, 6 plus minus 4 is 2, 2 plus 0 is 2, and 0 plus minus 3 is minus 3. For multiplication, again, there are some restrictions with the size of two matrices, but the restriction is if we have a matrix A of K times N, which is a number of rows, a number of columns, and B with the size M times N, which is a number of row and column. So in order to multiply two matrices, then we need to have the first matrix, the number of columns in first matrix should be equal to the number of rows in the second matrix, where the resultant array will have the number of rows in the first matrix by the number of columns for the second matrix. So in multiplication, we just take row I from A and column J from B, then multiply the corresponding and adding up the results. Alright, so here is our rule that should be there to multiply two matrices. Number of columns matrix A should match the number of rows of matrix B. Let's check out this example. Here we have two matrices of size 3 by 2, both of them. Therefore, those two matrices, the multiplication is undefined, but we can add them. All right? Okay, let's check another example. Here we have the first matrix of 1 by 2, and the second matrix of 1 by 2. So the number of columns for the first matrix is equal to the number of rows of the second matrix. Then here we can multiply. The resultant matrix will be equal to number of rows on the first and a number of columns of the second. So here can be multiplied because here we met the condition, and here is the array, the matrix, the resultant matrix size. All right. Another example is we have here the first array of 3 by 2 and the second one is 2 by 2. So what we usually do is we take the full row, multiply by the full column and get the first entry. Then we take the first row, multiply by the second column, and then we got the second entry. and we do for the rest. So here the results of multiplication. Since the first matrix is 3 by 2 and the second is 2 by 2, then the multiplication is defined and the product is 3 by 2, which is this is the product of A and B. And here we reach the end of part 1. We just introduce basics of things about matrices, name, entry size, and then we saw how we can apply the operations of a matrix. Keep in your mind, keep going, keep growing. Thank you. See you on next